Hello everyone, I'm here to make a video about the question 15.22. Let's read over the question first. Study here's a spring with the spring sentence K equal to 10 Newton per meter, as I write it here, 10 Newton per meter, and the ball is attached to the spring and allowed to come to rest, as in the first picture in the indicate that the ball is in the equilibrium position, and then if someone put it down to 3.5 centimeter and then release, then you could predict the ball will go oscillation up and down, like cross the equilibrium position here, and in the amplitude from the maximum position to the negative position, which is negative amplitude. So the amplitude A is equal to 3.5 centimeter, as the question says so. And also we can get the period as 19 seconds over 25 to get how many seconds one period need to make one cycle. And the question is asking the mass of the ball M and the maximum speed v, velocity v, mass. And the following we will go through the first question and the second question, and then finally make the assessment of the results. And through we know about the formula for the period, we have period equal to 2 pi square root with m over k as this one. We have the data for period and k, so we are supposed to solve the m through this formula. Let's write down, which is we can get the m is equal to k over 2 pi square k, and let's plug the number to the expression, which we will get 19 over 25 second square times 10 Newton m and over 2 pi square. And using the calculator, we can finally get the m is approximately equal to 1.15 kilogram here. So we got our answer. And for the second question for the velocities, maximum of the velocity, like we could recognize this one is the simple harmonic oscillation. We share the features of the position formulas as x t equal to h cosine omega t, and take the derivatives of the position, we can get the velocity equation, which is v equal to negative a omega sine omega t. So through this, we could easily get the formulas of the velocity, mass, when the cosine equal to -1, like you could get the maximum is a omega, and the omega is equal to 2 pi over t, so we can keep going to write it as this and put into our number to 3.5 centimeter times 2 pi over 19/25 seconds. And using the calculator, we can get the final result of maximum V is approximately 29 centimeter per second. Finally, we are going to the assessment of these two results. So for the first one, I think it is reasonable to be like, at least it should be positive, right, for a physical mass. So it should be bigger than 0 and smaller than 1 kilogram. I think it is reasonable because, for example, if it get to 1 kilogram and we're using this formula, we could get the results like it take like approximately about 2 seconds to complete one period, which is not making sense because initially it could use less than 1 second to complete one oscillation. So I think 1 kilogram would be really big, like big, and make the period also getting bigger. So it should smaller than 1 kilogram and bigger than 0. Therefore, the answer of this is reasonable. And the second assessment for the velocity, I was like start from this. I think it's reasonable to in like between 18 centimeter per second to like the double of 18, which is 36 centimeter per second. How I get this is that 18 actually is the average speed. Like one period it takes less than 1 second, and the amplitude is 4a. Using 4a, let me see, 4a, which is how long it goes per period, and 4a over the period is approximately to 18 centimeter. So that's how I get the average speed. So I think it have to bigger than the average speed, but smaller than the double of the average speed. The maximum speed should be smaller than the double of the maximum speed. So it's reasonable to be 29 because it is within this range. So in conclusion, I think these two answer is reasonable, and here it is. Thank you for listening. See you.